would like to share with you a number of insights we got from working in a non-model organism, both in terms of genomics and the genome sequence. As we all know, next generation sequence techniques, in general, the fact that sequence is so much cheaper now, allow us to use many non-model organisms to tackle many interesting and important questions in evolutionary biology that we were not able to tackle some time ago. Now, the non-model organism we chose to use is the Ninespine Stickleback, and the reason why we chose it is partly to be special and because it's a nice pretty fish, and partly because it exhibits a very large phenotypic diversity in different environments. So it is an ideal organism to study the genomics of adaptation. Now, how do you study the genomics of adaptation? We managed to get lots and lots and lots of data. Specifically, we got SNP data for 3 F2 crosses of about 800 individuals total, obtained by single-end rat sequencing. We have managed to have rat recent genome based on one individual sequence by depth, and in addition, we have more than 150 low-coverage genotypes for 11 different populations. So the first lesson we learned was that even though next-generation sequence techniques are by themselves a moving target, and so is all the bioinformatics pipelines. Once you start doing the work, you should concentrate on trying to get the most out of the stuff you have, rather than to worry about what could have been done had you waited a year or two, because otherwise you'd never really get anything done. A very important thing when you are talking about the genome is assembling it. And many people who work in non-model organisms have got the problem of not having a linkage map. The reason why not having a linkage map is a bit of a problem is because a linkage map is incredibly helpful in resolving misassemblies and anchoring sequences at the chromosome scale. Unfortunately, to get a linkage map, you actually need to have an F2 cross or a very large pedigree with many individuals that you don't genotype. So the second lesson we learned is that even though getting a linkage map for a non-model organism is not exactly going to give you a nature paper, it's still a vital step that will help you massively. And so are many other things to do with genomes that are not glamorous, but at the same time are very important. This is a quick scheme of our work pipeline. So on hand, we called the SNPs from rat sequencing, and we built a linkage map, and in parallel, we created the genome for the draft reference, and we assembled it using the linkage maps. Once we assembled the genome, we could build very quickly the low coverage genomes, and because these represent 169 different individuals, we could add new and very important QC steps for the SNPs we use to build the linkage map. By creating this new QC step, though, we were forced to go back, rebuild the linkage map from scratch, then check again the assembly, and so on and so forth. That had to be done a few times around. And so our insight in this particular thing is this is a process which is often very iterative, so there's no shortcuts, and it takes a lot of time. But that is something that cannot be avoided. And another important insight we must get is that genomics is logistically complicated because it requires enough computational power, you have a lot of data you need to be able to store, you need to back up this data, you have to put them by pipelines, you need to version the data, and so on and so forth. This requires thinking about it beforehand. And there's also more to do because the genome needs to be annotated, and so will need the SNPs so they can become a general resource. The question, so as you can see, it's a lot of work. Is it worth it? Obviously, yes. And you don't need to look elsewhere from this conference. So many people do this kind of work because it's so valuable and opens up so many opportunities to do excellent research. So, in summary, the logistics of genomics are really complicated. It's very important not to take it for granted. Some work might be unfashionable and not a nature paper, it's still important. And it takes a lot of time, but it's definitely worth it. Thank you very much.